Hi everyone, and welcome to the very last video about mechanical vibrations of systems with 1 degree of freedom. I brought the experiment again and I will demonstrate to you forced vibrations in systems with 1 degree of freedom. In the previous lecture we discussed free vibrations, so vibrations of the system without any external forces acting on the system. And in this last lecture series we will look at forced vibrations. So what happens if there are external forces acting on this system? And we will discuss a couple of things. First of all, I will explain to you how we can solve for the response of the system as a function of time for any arbitrary external force. So that is quite a powerful technique. For that we need the solution procedures that we discussed in the block on the theory of ordinary differential equations, so that comes back. And we will use it to, for instance, solve for what happens to the system if it is subjected to a constant force. So if there's just an external force pushing the system in a certain direction, the result will be like this. How can we describe what is going on here? So we will first do this for a couple of arbitrary forces, but then, and that is very important for the analysis of mechanical vibrations, we will look into external loads that are harmonic, so harmonic functions in time, sines and cosines. And the reason that that is important is that for vibrations we have oscillations, oscillations that damp out. So if the external load is also harmonic, sines and cosines, it is most likely to cause vibrations. And we are interested in the magnitude of these vibrations because in this way, only in this way, we are able to analyze if these vibration levels remain acceptable. So let me try to demonstrate what happens if we excite the system harmonically. So I take one end of the spring in my hand, and suppose that I can now, I show you that my hand moves from left to right in a harmonic fashion, or I try to be harmonic in this way, and you see that the card also behaves harmonically. And I can do this with different kind of frequencies. I can be very slow or very fast. Well, in this case you see that I'm very fast and it almost doesn't move. Okay, so we're interested in how much does this amplitude, the vibration amplitude, depends on the frequency with which I am exciting the system, either fast or slow. And in this procedure, as we will go through the derivation, we will discover that there is one scenario, that there is one frequency with which it's very easy to get the system to exhibit large vibrations. Watch me do it like this. You see that my hand only moves like a very short distance, okay, but the vibrations in the system are very, very large. This is what we call resonance, and it occurs whenever the frequency of the excitation matches exactly with the natural frequency of the system, all right? That is the reason why it is so important to determine the natural frequency of the system. So if you think back of these lectures on free vibrations, maybe you can remember that one of the first things we did is establishing the expression for the natural frequency of the system. If we already know this natural frequency, we can assess whether or not this phenomenon called resonance occurs if we know the excitation frequency. So for establishing whether or not resonance occurs, we do not need to do any calculations on force vibrations. We only need to check if the natural frequency matches the excitation frequency. But if we really want to describe what happens mathematically, so maybe let me do it again. If we want to know what kind of mathematical function describes the fact that at time is 0, the card is at rest, and then I start moving in a harmonic way. And if t increases, the amplitude of vibration increases. If I really want to describe this behavior in time, The techniques we need for that, I will also explain that to you in this lecture series. So there are 4 video lectures coming up. The first 2 are devoted to arbitrary excitation. So how can we describe the response of the system no matter what external force applies on the system. And the latter 2 are used for the situation that we have harmonic excitation. And I will explain to you how we can determine the response of this system and how and what happens to the system when it is in resonance. So after that, we are really done with everything related to systems with 1 degree of freedom. After that, we will move on to systems with 2 degrees of freedom. So I think after this block, we really have finished something, which is very nice. Yeah, I would say stay with me during these last video lectures on 1-DOF systems, and then I will come back to you again with a new video on 2-DOF systems whenever you're ready. Okay, thanks for watching. See you next time.